Bitmap indexes. Bitmap indexes are generated using ones and zeros. So if you look carefully there, look at the bottom diagram, you can see that the state equals California is switched on with a 1 or switched off with a 0. So if you look at the first 4 rows in the bottom part of the diagram, you'll see 4 ones. You go look at the first 4 rows in the top part of the diagram up here, and you'll see 4 states of California. So 4 ones, 4 California. 4 zeros because Nevada is switched off. You look at the next 2 rows, you've got 2 states of Nevada switched off under California, switched on under Nevada, and then another 4 Californias, 4 switched on, 4 switched off. What does this do? Well, first of all, this index cannot be rebuilt on the fly. It will overflow automatically as soon as you change data. Be very careful with bitmap indexes and any DML activity. I have seen one particular database years ago in Northern California that wasn't really that big, but every single index was a bitmap index, not a B tree. I don't know why they did that, but it took me a while to persuade them to remove them because they had some updates that were taking 8 hours, and when they removed them and changed them to B trees, everything ran in a few seconds. Anyway, aside from that point, don't use bitmaps where you're going to update stuff. Typically they get used in data warehouses on very restrictive or relatively low cardinality values, such as columns containing male or female or states, where, for instance, I've only got 2 states in here, but even so, if I've got a lot of data with a lot of states in, that there's 51 states in this country, and I've got a gazillion rows, well then obviously relatively the state count relative to the number of rows in the table is low. Low relative cardinality, not just low cardinality. It can make bitmaps efficient as long as you don't change the data. What actually happens is that it's basically switching on or off. So you would go into the data. The search would put in, let's say, state. It would go into here and it would have the column state California, and it would find all the rows that are state of California. Obviously there's a lot of duplicates. As a result, a bitmap index can obviously not be declared as being unique. There wouldn't be much point if you think about it. But essentially what it's doing is it's going to find me all the rows that are California very rapidly, because this index space here is a lot smaller than a regular binary tree index, which first of all stores the data values as well as the row ID. This is 1 and 0. It's a very small discrete chunk of IO, so the index is much more compact, but it reads a lot more rows obviously because it has to read all the state of Californias. So basically you say state of California, it's going to find all the rows that have a 1 in there, find all the row IDs and find all those rows. This is why it's efficient, but be careful, no updates, otherwise you will have big problems. But it's very simple. It's just a bitmap. This is what a bitmap is, a row ID with a map of bits switched on or switched off for the specific values. If I had 50 states in this table, I'd have 50 columns. If I had 50 rows in the table, that would be inefficient. If I had 50 million rows in this table, this would be efficient because relatively I have 50 states versus 50 million rows. I can't remember what the exact recommended percentage is, but it's pretty low. You want to look at a few percentage points and you want to test it to make sure it is useful, because if it's not, then get rid of it and use a B tree. And here I'm basically showing is the link between the first row, which is San Francisco CA, and obviously I'm linking the row ID. If you can see the last 4 letters on this particular row ID are KAAL, and there's KAAL, and I'll go to another row, and I'm obviously linking this last row KAAV to KAV. I'm just showing you that the 2 rows are linking together between the data and the bitmap index. This is actually a diagram that represents the table data, and this is a diagram that represents the bitmap index. So when you search the bitmap, you find all Californias, if you're looking for California, and you will find all the rows in this table based on the row ID for California, 1, 2, 3, 4, 5, 6, 7, 8. If you search for Nevada, you find 2. Obviously, you're going to get quite large differences in search times based on the fact that you have 8 California rows and 2 Nevada rows. Obviously, if you extrapolate that up to a table of 50 million rows and relatively the same ratios of California and Nevada, you're going to be spending a lot less time finding the Nevada rows than you are the California rows. And the optimizer may even say, well, we don't need to use the bitmap because it's inefficient. If we're reading 80% of the rows as California out of 50 million, we might as well read the entire table. So don't expect an index, a B-tree or a bitmap to always be used, because it may not, because the optimizer may find that it's more efficient to not use an index. Don't force it to use an index unless you're sure it's actually going to be faster.